Okay, this video is about the rank of a matrix and matrix inverses. Specifically, we're focused in on the inverses right now. I need to define for you an augmented matrix. So if A is an M by N matrix and B is an M by P matrix, the augmented matrix AB is an M by N plus P matrix, whose first N columns are the columns of A, and whose last P columns are the columns of B. And we'll have an example here in a moment. But we're going to use this to find the matrix inverse. So if A is an invertible N by N matrix, consider the augmented matrix A identity matrix. So in this example, we'd have 3, 2, 1, negative 1, 4, 0, 6, 0, 2. So this is the first three columns. And then the identity matrix, 1, 0, 0, 0, 1, 0, 0, 0, 1. So you have 3 rows, now 6 columns. You can put a dashed line or not. Okay, so if you multiply this matrix by an elementary matrix, you get E1 times A, and then E1 times the identity matrix, which is just E1. And you'll actually show in your homework that this is true for any matrix. You can multiply through and just entry by entry, you can double check that an entry in the left side is this and an entry in the right side is this. But we'll actually show together, hopefully in another video, that every matrix inverse is actually the product of elementary matrices. So our goal is to find a sequence of elementary matrices so that you can multiply, and that times A gets you the identity matrix over here. What do you end up in the right? On the right, you end up with A inverse. So A inverse is just sitting there. So let's practice with this matrix down here. Okay, and we're going to do elementary row operations, which are equivalent to elementary matrix multiplication, right? So I'm going to use a method called Gauss-Jordan elimination. I'm going to get a 1 there, 0, 0, 1, 0, 1. So I get those 1 diagonals, and then I'll put zeros back there. So to start with, I want a 1 there. I'll just multiply the first row by 1/3. So 1, 2/3, 1/3, 1/3, 0, 0. These left unchanged. Now, I'm going to try to eliminate these two by adding multiples of row 1 to these other rows. So to start with, row 2 plus a single row 1. Can you see what's going to happen there? I'll get a 0 there, right? So this is 0. 4 plus 2/3, that's 12/3, plus 2/3 is 14/3. Then 1/3, 1/3, 1, and 0. Top and bottom rows stay unchanged. I should say this is not the only algorithm to get here, but I do like Gauss-Jordan elimination. So row 3, what do I need to do here? I need to subtract 6 times row 1. So row 3 minus 6 ones gets me 0. 0 minus 6, what is this? 6 of these, well, let's see, 6 of that the 3's reduce, so I have 12/3, which gives me minus 4. And what do I get here? 2 minus 2 is 0. 0 minus 2 is minus 2. 0 minus 0 is 0. 1. Okay, and the other 2 rows are unchanged. So 1, 2/3, 1/3, 1/3, 0, 0, 0, 14/3, 1/3, 1/3, 1, 0. Okay, the first column is just the way I want it. Now I want to make this a 1. So I'm going to take 3, 14ths times row 2. So 0, 1, 3/14 times a third gets me 1/14, 1/14, 3/14, 0. Top row unchanged. Bottom row unchanged. Now I'd like to get rid of that number there. How can I do that? I'll take row 3 plus 4 row 2's. Okay, so 0 plus 0, -4 plus 4, 0 plus 14 times, 4 times 1/14, which reduces to 1/7. Then -2 plus a 7th. Let's see, so that's negative 14/7 plus 1/7. Sorry, no. This is negative 14/7 plus 4/14, which is 2/7, right? And sometimes I just have to have scratch work off by the side. That's negative 12/7. Then 4 times 3/14, that's what? That's 12/14, which reduces to 6/7. And then here, 1 plus 0. Yeah, okay. And now I'll keep these unchanged. Okay, so I've got this the way I want it, this the way I want it. I need a 1 there. That means I'm going to have to multiply this by, did I not do that right? I think I had 2/7 there. 4 times 1/14 is 2/7. There we go. Okay. Let's keep going. I need to take this row and I need to multiply by 7/2 row 3. Okay, so I'm going to take this row 0, 0, 1. Now this times 7/2, let's see, that's going to be -6. 6/7 times 7/2, that's going to be 6/2, or 3. 1 times 7/2 is going to be 7/2, right? And these are unchanged. 1, 2/3, 1/3, 1/3, 0, 0, 0, 1, 1/14, 1/14, 3/14, 0. Okay, I'm getting close. I need 3 more zeros to get the identity matrix there, so I'm going to take row 2 and I'm going to subtract 1/14 row 3 from that. So 0 minus 0, 1 minus 0, 1/14 minus 1/14, 1/14 minus, let's see, what is this, plus 6/14. That is 1/14 plus 6/14 is 7/14. That's 1/2, right? 3/14 minus 3/14 is 0. 0 minus 1/14 times 7/2. Okay, 7/14 is 1/2. So this is 1/2 times 1/2, -1/4, right? Okay, and then I'll copy the top row. 1, 2/3, 1/3, 1/3, 0, 0. Bottom row, 0, 0, 1, -6, 3, 7/2. Okay, I need to eliminate these 2 entries. So I'm going to start by doing row 1 minus 1/3 row 3. What's that going to do? 1 minus 0, 2/3 minus 0, 1/3 minus 1/3, 1/3 minus 1/3 times -6, so that's plus 2. So 1/3 plus 2, that's 7/3, right? 0 minus 1/3 times 3, so that's -1. 0 minus 1/3 times 7/2, so that's -7/6. 0, 1, 0, 1/2, 0, -1/4, 0, 0, 1, -6, 3, 7/2. Okay, we're just 1 away. I just need to get a 0 there. I miscopied that 1. That's a 1 from the 1 minus 0 above. Okay, so we just have one thing left. That is row 1 minus 2/3 row 2, right? So 1 minus 0 is 1. 2/3 minus 2/3 is 0. 0 minus 0 is 0. 7/3 minus 2/3 times 1/2. 2/3 times 1/2 is 1/3. So 7/3 minus 1/3 is 6/3, or 2, right? -1 minus 0 is -1. 7/6 minus 2/3 times 1/4. Okay, so 2/3 times 1/4, that's 1/6. So we're adding a sixth. Adding a sixth gives me -6/6, or -1, right? And then what do I have? 0, 1, 0, 1/2, 0, -1/4, 0, 0, 1, -6, 3, 7/2. Okay, so can you see that I have my identity there, and I have an inverse right there. If you're looking for the inverse of this matrix, see, this is what I have. This is the inverse. We've used this process to get A inverse. It's 2, -1, -1, 1/2, 0, -1/4, -6, 3, 7/2. There you go.